Hi everyone, in this short video I'm going to demonstrate how to use Excel to calculate a few simple summary statistics, the mean and the standard deviation, and then how to use some of that information in a word processor document if you might be preparing an assignment for your teacher to submit. So I have here a short list of random numbers which I want to find the mean. Now there is a built-in function that we could use, but we probably want to do a few extra steps here. So in order to calculate the mean, I need to know the sum of these numbers. There is a function called sum. Notice I start with an equals and then there are brackets to contain the data range there. Close the brackets and I find that these all add to 704. I'll probably forget what that means if I don't write myself a label. So it's important to document what you're doing here. So I'm just going to put the sum of x beside that to remind me. The next thing I need to know is how many there are. Excel has a function called count and does exactly what it sounds like. It simply counts how many data values are in that highlighted range, and I'll put that little note there for myself as well. If I want to know the mean of these, then you guessed it, start with an equals, 704 divided by 13, and we get the mean, 54.15. Just reduce the decimal slightly. Now, there is a built-in function that you could have used, but it's just as good to use your knowledge of mathematics as well. Why do you think I wanted to put cell references here? Well, what if one of the data values I go back and find there was a typo? Instead of 51, that was supposed to be 15. Then the fact that these were formulae, it updates the sum, it updates the count, and the fact that this cell contained formula referencing these results, it updates that answer as well. That's the true power of a spreadsheet. You want to use formulas whenever possible, rather than just typing in raw data. The only real place you want to type in the numbers is in the place for the raw data. So now that we know what the mean is, we need to go to our word processor and somehow write this down and justify the working. So here I am. I'm not just going to launch straight into the maths. I would of course put some sort of a statement. The mean of the scores is calculated as shown in equation 1. So always refer to the equations in the written part of your answers. Now, the insert ribbon contains a section called equation, and this is where I start to type my equation. So the formula for the mean, of course, to start off with, we have a whole lot of different little sub-menus here. There's a lot, it'll take a while to find everything, but I know where this one is. It's under the accent menu and it's down here. It's a bit small for me to see from back there. That's it. It's the one with the little horizontal bar. So I click back into the placeholder and type x equals. Now I need a ratio between the sum of x over n. Notice how that changes as I move the cursor right and left with the keyboard. At the moment my cursor is outside the equation box. Now the cursor is inside the equation box. There's an important difference. If I press Shift Enter when the cursor is inside, it gives me a new equation box on the next line. Just what I need. And I need a ratio. Now I'll go back to Excel and remind myself of those numbers. 668 over 13. Once again, Shift Enter equals and 51.38. That time I've moved the cursor outside the equation box before I pressed enter, so I'm back to normal text. The one last thing that we probably want to do is highlight the three equations, do a right click anywhere you can and align the equals signs just to make the presentation look a little bit neater. So the mean of the scores was calculated as shown here. Then I would go ahead and discuss what the mean represented in the context of my question that I was answering. So that's the first one. The next one, if I wanted the standard deviation. So yes, there is a formula for standard deviation that Excel can calculate, and I'll demonstrate that now. So I'll just put a little label here. The formula starts off with ST, and it gives you suggestions. Here they are. The one we usually use is the sample standard deviation. So this time I'll just double click and it finishes typing it for me. It's put the brackets. I'm up to the stage of highlighting the data range, close the brackets, and there's my sample standard deviation, 30.03. So I go back to my word processor, and here I go. I'll launch straight into doing an equation this time. And the formula for standard deviation begins with the symbol sigma. These standard symbols you probably find up here. In fact, I think sigma will be just there. Sometimes you won't find what you need. You have to use that little one there to choose other options. Now, of course, all the Greek letters are available, capital and lowercase, so it doesn't really matter if I choose sigma from here or there. My formula for standard deviation begins with a square root sign. Inside the square root sign I have a ratio. The numerator is the sum of, so I'll put the brackets, and inside here I will have x minus the mean. So each score subtracted, have the mean subtracted. Now I need to square that. I'll demonstrate a keyboard shortcut. I could go up here somewhere and find a way of putting in squares, but it gets a little bit funny. You see how it's not including what I want there? So if I'm sitting at the point where I want to have an exponent, I can use the caret symbol, put the 2, and then when I press the space bar, it reformats the thing for me to be correct. Down the bottom here, I just want n-1 for sample standard deviation. I'm ready for the next line. Now that was a lot of typing, so I can copy and paste into the next equation box and just change the bits that I need to change. So, well, n was easy enough. If I pop back to Excel, n was 13. So I can update that to show my working. But the top one's a bit different, isn't it? I need the deviations, I need to square them, and then I need to add them all up. Now that's way too much work to be showing in a report. So I'll do some of the hard work up here for me. Again, I'll put some labels. These are the deviations. So the deviation was literally the score subtract the mean. Well, in the first case, that is 56, subtract, and the mean is down here in cell B20. Now that looks like it'll work just nice. I want to be a little careful though. When I copy this formula down the page, I'm absolutely wanting B3 to update in the next cell to reference B4 and so forth. But I don't want B20 to update. I want B20 to always be subtracting this score, 51. In order to do that, press the F4 key and it changes the reference here to absolute. The $ on the B and the 20 mean that when I copy that, the B20 will not update. The no $ on the B3 mean that it will update as I copy down. It'll change to B4, then B5, and so on. So there is my deviation for the first one. Using the copy handle here, copy that down, and just let's inspect the next formula. B4 has changed, but B20 is still pointing at the mean. That's what I wanted. As I continue moving down, I'm just going to check here by looking, and B5, B6, B7, that's all working nicely. If I recall this formula, it wasn't the deviations I needed, it was the squares of the deviations. So I'll need to put in a new column. This will be the deviations squared, and that's just a text label to remind me what I'm doing. So I'll start my formula with an equals. I'll point to cell C, C3, and then exactly the same thing. Caret symbol 2 means squared. Now, don't need anywhere near that many decimals, so I don't know why it did that. And now I'll copy those. So each of these is a squared deviation for every score in the list. What did I need to know? I needed to know the sum of those. So I'll add that column And this number, very large, this number is exactly what goes in my formula. It is the sum of the squared deviations, 10,821. So the entire numerator is 10,821.08. Can't forget the 0.08. Again, I stress, this is for justifying our answer. Now, that's something we can either do on the calculator, or better yet, we could do this on Excel. We could literally say, what is the square root of this number divided by, we had 13 minus 1, so 13 minus 1, close that brackets to calculate the n minus 1, close the brackets on the square root. This is my standard deviation, 30, and it matches exactly what Excel told us. The advantage of doing it like this is I have this number here to show in my working. So 30.03 is the answer on the next line. Outside the, there we go, and I'll just align the equal signs there to make that look, something went wrong. Why can't I align the equal signs? Occasionally it misbehaves. It's got to be pretty careful about what you select. If I accidentally selected anything outside the equation, it didn't give me the choice. So there is a very quick rundown of just how we use Excel to calculate a few simple statistics, and it's not just about the answers. It is not just about the answers. We do need to show some of these numbers to put into our working, and Excel can help us figure those out as well. That's enough for now. If you have any doubt, you can replay this and pause, or check in with your teacher. See you next time.